Chapter 9 Support for Dungeon Creatures, in which our player character walks around the dungeon map for the first time. A structure for moving mobs, taking turns in dungeon, and first moving player. We have reached a pivotal part of the game to make. By now we have our dungeon map, the playing area. We have so far used our drawing capabilities to make a pretty picture of a dungeon. But it's very static and nothing is happening yet. To arrive at a game, something must be able to move around and make choices. What we lack are moving monster creatures in there, that are able to take turns executing their chosen actions. The player will be such a creature, and so will his computer-controlled NPC enemies. The player should be able to move his @ sign, and monsters of some kind should walk around and act in the dungeon as well. Otherwise the player would be quite alone in there and lack opponents to challenge him. Creating the supports for such moving action-taking creatures is a major undertaking. It requires a number of mechanisms in place and can only function with their full combination. This means we will have to create and complete this entire set of features before we get to see them do anything. The feature set we are about to build consists of these parts: a mob class to track each creature, its position, name, and so on; a turn queue, a list of all alive mobs to track their turn order; integrating the mob and the turn queue into map cell and map, so we can draw the monsters with the map and know where they are in the map; a game screen that draws the map and executes the player and creature turns; a past player helper class that maps player input to game turns; an upgraded builder that builds players and monsters, not just the dungeon map; a screen maker to combine our new screens. In principle, we could hack it early and, for example, demo just a solo player walking around on the map before we had all the parts above made, maybe without the turn queue. But it wouldn't really be useful for anything, because most of that tried out work would have to be thrown away again and replaced with the later proper mechanisms. We would not be able to reuse the effort for anything. So prepare yourself for building 6 features in a row, which we can only try out once all 6 are in place. Player and monsters as mobs. For our moving bits, we introduced the concept mob from mobile or mobile object. The player will be a mob, and the monsters will also be mobs. Let's consider some properties that mobs will need: an XY coordinate position, a glyph or character to draw it as in the dungeon map, a name so we and the player can tell what is going on, and some way to know if it's the player or not. So here we have the mob class. We'll need to expand our glyph a bit to also represent mobs. So we add player and bad cat. Integrating the mob with map cell. Our mobs should walk around in the map and thus appear on our map cells. So we add a reference to mob in our existing map cell. For a given cell, its mob property will either contain any present mob or else have the value undefined. This means only a single mob can occupy a map cell at a time. Notice how we change glyph to show the glyph of any present mob, so the draw map now automatically shows any mobs too. A turn queue of whose turn it is. What we did above will enable us to represent, hold, and display mobs, but it's still just passive description. To get our mobs active in the game, we'll introduce another concept, a turns queue or mob queue. It will be a sorted list representing the order in which the mobs takes their turn. It works like this: we'll let the first mob in the queue take his turn, then we'll remove him from the front and re-add him at the back of the queue, and that is all. We will just repeat this sequence until the game ends. Whenever the front mob is the player, we'll ask the computer for keyboard input to decide his turn. If the front mob is a computer monster, our code will decide a turn for it. Here's the turn queue class. Integrating turn queue into dungeon map. We will place the turn queue inside the dungeon map. We do so as the map already keeps track of the mobs inside the map cells. To keep it all consistent, this secondary tracking of the monsters is best kept in the map as well. So the class dmap gets these additional parts. We extend the interface dungeon map with these new methods. Enter map is a bit special. We use it to let the player arrive on a map. The player is the only mob who will be able to travel between levels, which means his position needs special care. We will need to provide a reasonable and correct position for him whenever he arrives on a level. That is, not inside a wall, for example. Also, we want the player to cut in line and always get in front of the turn queue, so we add him with front push mob instead of push mob. The game screen handles mob and player turns. We will need a screen for this, a game screen which will handle turns for the player as well as for the NPC enemy mobs. Here a raw draft of the game screen. This is just a draft, because neither the player nor the enemy mobs actually do anything here. But the main needed mechanism is present. Whenever we receive a keyboard input in on key, player key turn asks player turn whether this can be passed into a turn for the player. For example, go north 1 step or hit monster east of me. If it can, the player turn is completed, and NPC turns then processes turns for the rest of the mobs in the queue until the player is once again in front. The whole while, we will watch whether the player has been killed. Otherwise, once the player died, the other mobs would continue playing forever among themselves without ever returning back from NPC turns to the event loop. That is, where the player could again solicit keyboard input. The game over method over handles that check. In case of death, it discards the game screen and activates the game over screen. This is where our earlier screen maker effort comes into play. It knows how to create that screen and how to pass it the necessary resources. To support the sketched approach, we must add the player property player to the game IF and game 0. Before we get too far with the game screen draft above, we will refactor it and split it into 2 classes. We will make a base class called base screen, which will handle all the NPC stuff, and derive a class game screen from it, where we put the player's main turn mechanism. We will eventually get a number of screens that do different kinds of player turns, and they all need to handle the same NPC stuff, which we conveniently keep in the base screen. In general, base screen will hold common features we need across many screens. Here a second attempt at game screen. Still no index n to test it, as we need more bits before it can actually do anything. Moving the player. For a while we can tolerate that the NPC monsters don't yet do real turns, but we really do need a basic implementation of player key turn to try out the moving monsters in the map mechanism. We want 4 direction keys to move the player north, east, south, east and west. We will make a class pass player which decodes keyboard input into a possible turn and executes that turn. First, fix player turn above to be this. Then 09 pass player is this. That was quite a mouthful. Let's explain its various parts. We foresee that the player will eventually have a lot of commands at his disposal, so we set up this separate class pass player for that. Then there's some stuff about a command interface, which is for all our fancy moves. All the spells and kinds of play turns we can do, we will put in command classes, which share a common command interface. This way all our mobs, the player as well as the enemy mobs, can use the same spells. Then we did an empty on W point, which we will have to add as this. And we use the move command out of thin air, which we need to provide, and it will be this. Move command calculates the new position NP by adding the direction to the player's current position. We use the plus method, which we can append to W point. Beware if you use add to that you will be modifying an existing point directly. For example, if you used it on direction above, that direction would suddenly contain a full point and not just an offset anymore. Similarly, if you use it on a mob's embedded point, that could cause trouble for map.moveMob, because moveMob needs the old mob position in order to clear the old cell. That is why we have both plus and add to. You might consider move command to be an awful lot of red tape for moving a monster in a single step. The idea behind it is that movement will eventually get a lot more complicated, and move command is where we put all that. Using your turn to wait. Finally, we have a wait command, which is a turn that on purpose does nothing. The player might use this, for example, if he is waiting for a monster to move closer to him in order to attack it from a favorable position. Maybe the player is standing in an advantageous position. Again, it may appear silly to use that much code to do nothing, but as our game becomes more complicated, waiting in place may also become more complicated. Maybe a resting player will have gathered extra strength for a powerful attack, or heals faster, or other kinds of side effects. Having an explicit wait command gives us a natural place to put such stuff. Apart from that, it is a good principle that all legal game moves, even the wait command, are expressed with the same structure. That is the command interface, CMDIF. This makes it explicit. We intend wait your turn as a proper move. Updated builder that also builds the player. To get started testing it, we first need a builder. We made a builder 0 in the previous chapter, but it was a map-only builder, which did not add a player. It didn't know about players and mobs. Our updated builder will look like this. Notice we use enter map and enter first level 0 to place the player directly in the map, outside of make level and make map. This is a deliberate choice. It keeps us in control of how and where the player appears when he enters a dungeon, through the enter first level method and its variants. The goal is to keep player placement out of level creation and map creation. This frees us to let gameplay concerns control how the player should move around and arrive. If instead make level would place the player, we could not change this. Combining our screens with Screen Maker. We will need a Screen Maker that uses our game screen. To run that, we'll extend it with a few helper methods. Testing the combined features. With that, we should be ready to test it out. There are no enemies yet, but we will be able to move the player about around the map. Let's whip up a builder, an index09 builder file to test it. Blocking walls and block tiles. The good news is that we can finally move around the map. The bad news is that neither walls nor the edge of the map is stopping us. We can walk right through everything. We need some mechanism so we can't walk through walls. We can update execute on move command to be this. So dungeon map and dungeon map IF must get this, and map cell must get this. This change means that attempts to move into an illegal tile will not count as a turn, but be ignored. We do not need a new index n for this. If you run index09 builder again, you should see the change. Viewport. Because we have a player walking around now, we can do a clever adjustment to the map drawing. We can center it on the player so the screen scrolls around as he moves. All it takes is this adjustment to draw map, and then a small adjustment to base screen. But base screen gets draw changed to this. And voila! If you run index09 builder again, the map and camera should follow the player around as he moves. A thought on mob positions. Consider that we could let the mob inherit from W point instead of having position as a property. It would be a bit dirty but quite practical for programming, since all our mobs will have a position and a lot of our code with mobs will deal with their positions. It would make a lot of our code simpler to write but less obvious to read.